Hi everyone, I'm Paul Drobny and I'm an AI resident at Abziva. For most of my career as an engineer in the semiconductor industry, I regularly analyze data to improve process control and to evaluate process and product changes. Finding insights from data has always been my favorite part of my job, and it led me to realize I want to make this more of my career focus. A few years ago, after some research, I discovered that data science had exactly what I was looking for. As an AI resident at Abziva, I get the opportunity to work on challenging real-world AI and machine learning projects in various industries. In this video, I'll discuss a project I recently completed where I utilized AI to predict customer happiness from the results of a customer satisfaction survey. A little background on this project. The client is a fast-growing startup in logistics and delivery. Currently, they are experiencing several different challenges they're trying to address. With a global expansion strategy, they understand that customer happiness is critical to their success. They would like to find out what makes customers happy or unhappy and take necessary actions. For our analysis, the client provided a subset of survey data from a select customer. We were given two goals by the client. The primary goal is to predict if a customer is happy or not based on the survey answers. They're also interested in knowing what survey questions are most important in predicting customer happiness and determine if any questions can be removed from the survey moving forward. The data provided by the client includes the target attribute Y, which indicates customer happiness, with 1 being happy and 0 being unhappy. There are also 6 survey question categories. X1, my order was delivered on time. X2, contents of my order was as I expected. X3, I ordered everything I wanted to order. X4, I paid a good price for my order. X5, I am satisfied with my courier. X6, the app makes ordering easier for me. Each question was rated between 1 and 5, with higher numbers being more in agreement with the answer and lower numbers being more disagreeable with the answer. The data was made available with the provided link to a CSV file. Once downloaded, the file was read and copied into a data frame. The head function was used to look at the first 5 rows for a quick check that the data was in the expected format. Now that we have our data available, we can move forward with exploratory data analysis. We first want to check the data for completeness and any missing values. With the isNull function, we confirm there are 0 null values or missing data in any of the columns. Next, we'll check that the data is in the correct format. Using a data type check, we confirm that the values are integers as expected. The describe function generates a brief statistical summary of the data, including mean, min, max, and with the quartiles, we can get a good idea of the distributions. For customer happiness, Y, we can see that values range between 0 and 1 as expected. The mean shows us that 55% of customers are happy. For our features, X1 through X6, we see the values range between 1 and 5 as expected. Some notable observations are the higher mean values of X1 and X6, with 75% of customers rating these a 4 or better. X2 has a lower mean than the other features, with 75% of customers rating this as a 3 or worse. For further insights into the data, I made count plots of happy and unhappy customers for each feature. For X1, my order was delivered on time. You can see a steady increase in the number of happy customers with increasing X1 score, while the number of unhappy customers remains relatively flat. This indicates a positive relationship to customer happiness and possibly a good feature for using in a predictive model. For X2, contents of my order was as I expected. There is no apparent relationship between customer happiness and X2 score, with the majority of happy and unhappy customers both scoring a 3 or less. For X3, I ordered everything I wanted to order. The number of unhappy customers dropped significantly with scores greater than 3. While happy customers also decrease, the proportion of happy to unhappy customers is almost 2 to 1 at scores 4 and 5, indicating a positive relationship to customer happiness. For X4, I paid a good price for my order. both happy and unhappy customers have similar trends with X4 score, indicating there isn't a stronger relationship to happiness. For X5, I'm satisfied with my courier. Both happy and unhappy customers increase with scores between 1 and 4. However, at a score of 5, there's a significant drop in unhappy customers, while the number of happy customers remains relatively high. This indicates a possible nonlinear relationship to happiness. For X6, the app makes ordering easier for me. There's no apparent relationship to customer happiness, as both happy and unhappy customers trend up with increasing X6 score. A correlation study was used to look for any linear relationships in the data. We look for correlation between the target variable in each feature to identify if any of the features are more important in determining customer happiness. We're also looking for correlation within the features. If two features have a very strong correlation to each other, this would indicate redundancy, and we may be able to eliminate some features. As we can see, the correlation values are all less than 0.5, which indicates weak correlation. So we have weak to no correlation found between happiness and the survey question scores, and we'll also have weak to no correlation found between the survey questions. Next, we can move to developing a predictive model. For model evaluation and selection, I chose 3 models that are commonly used for binary classification. Logistic regression estimates the probability of the outcome being a 0 or a 1. Random forest is a decision tree-based model that is good at handling nonlinear relationships by identifying features of most importance. Support vector classifier SVC fits a hyperplane to separate points of different classes. To evaluate the models, a confusion matrix will be used to summarize the correct predictions. We'll be looking for overall accuracy, the percent of true predictions compared to the total predictions. We'll also be looking to maximize the true negative recall, which is the percent of true negative predictions compared to the total negative predictions. The reason for this is there's higher risk to missing an unhappy customer compared to missing a happy customer, as we want to make sure all the concerns and issues are captured. Recursive feature elimination will be used on the best model for feature selection. And finally, the best model will be retrained using the selected features. For each model, the hyperparameters were optimized for overall accuracy using hyperopt. The models were then trained and fit again on the best hyperparameters. The models were then evaluated with a classification report and confusion matrix. The best performing model was found to be random forest, with an overall accuracy of 81% and an unhappiness recall of 75%. The other 2 models did perform well for overall accuracy with scores of 73 or better, but performed poorly in unhappiness recall in comparison to the random forest model. Now that we have our best model, we move forward with feature selection with the goal of getting equivalent or better model performance with a reduced feature set. Recursive feature elimination, or RFE, was ran looping from 1 to 6 features. The best feature set was determined by the maximum unhappy recall score. RFE determined the optimal number of features is 3, selecting X1, X3, and X5 as the most important features, which lines up with our earlier observations from exploratory data analysis. With our features selected, the trained test splits were transformed to include only X1, X3, and X5. The random forest model was then retrained and optimized again on the selected features. With a reduction in the number of features, the overall accuracy was maintained at 81%, and the unhappiness recall improved from 75 to 88%. With this project, we successfully achieved the client's primary goal by developing a model to predict customer happiness based on customer survey results, with an 81% overall accuracy and 88% recall detecting unhappy customers. We were also able to achieve the secondary goal of improving the model with a reduced feature set, identifying the most important survey categories as my order was delivered on time, I ordered everything I wanted to order, and I am satisfied with my courier. From these insights, the client can decide what actions to take, where the goal is trying to improve customer ratings in each of the categories, or by eliminating less important categories from the survey to focus efforts on the more critical categories. For more on this project, you can check out my article on Medium or the project repository on GitHub, or feel free to connect with me on LinkedIn by clicking on the links in the description below. Thank you for watching this video.